Hello folks, this is Nitin welcoming you to the AI University channel where you can learn all your favorite digital technologies like machine learning, deep learning, AI, big data, Hadoop, virtual reality, augmented reality and cloud computing. In this video, I am going to show you the Python Pandas equivalent statements of SQL or SQL queries from the perspective of performing exploratory data analysis before we build any machine learning models, right? So that's the approach we take. We perform some exploratory data analysis before building any machine learning models. Most of us at some point in time might have come across SQL relational database queries to present the data in clean and presentable format. So sometimes we used to or might have already created certain reports on a relational database, right? And we utilize these queries, SQL queries, to build those reports. Now these queries seem to be very easy to write, but gone are the days when data used to be available in tabular or relational database form. Now data these days is available in various shapes and formats like .csv, .xls, .txt, .json, etc. So Pandas library is very useful in performing the data transformation, data manipulation and analysis related tasks when presented with data in the format mentioned earlier. And it would become very easy for us if we could have a quick reference guide using which we could write SQL query equivalent operations in Python Pandas. So this is going to be multi-part series which will cover Pandas equivalent operations of SQL constructs like select, order by, group by, select and where clause, distinct, in, not in, count, having clause, or sometimes like aggregate functions like mean, max, min. Then we have join operators, union, insert, update, etc. So I will in a way cover almost all SQL constructs to write equivalent operations in Python Pandas. So Pandas library also supports chaining operations using which we can combine several Pandas operations together with the help of a dot operator with an intent to transform data in desired shape. Okay, so without further delay, let me show you the Python Pandas equivalent of SQL constructs. So let me open my Jupyter notebook. So this is my Jupyter notebook. So in the first cell, I am importing the Pandas library first. Okay, and then after that, I am loading the mall customers CSV file. Okay, so this is the file and it contains these columns like customer ID, genre, age, income, annual income in $1,000. Okay, so this is going to be 15,000. This is going to be $16,000. So here I am just loading this data using read underscore CSV file method. Okay, so read underscore CSV method. And I'm creating this data frame by reading this. I'm creating a data frame called customers. So I will start first with very simple select statement. So in the next cell here, so I have first written the SQL statement here Python equivalent code of which is written in this next line, right? So I'm going to follow the same approach for all the SQL queries. Okay, so our query is select star from customers here, right? And which will actually select all the records from the table, and table here is, let us say, let's consider this is customers table. So let us say we have this SQL query select star from customers. Okay, and the Python Pandas equivalent of that query is just this particular statement, which is customers. So by typing the name of the data frame, we can get the same result which we will get with this particular query. So when I ran this cell, okay, it printed all the 200 rows and 5 columns. As you can see, 200 rows and 5 columns here, right? Though you will not you will see just a snapshot of the entire data. Not all the records, all the rows are printed here, just a snapshot of it. But thing is, it printed all the records available in this particular table. Okay, and the Python equivalent is customers here. In the next cell, we have another query, SQL query, to select all the records from the table, but printing only 7 of them, right? And here limit is used in SQL query to limit the number of records, right? So this limit construct, what it does is it just prints the number of records which are mentioned here, right? So the Python equivalent of that SQL query is customers dot head and in brackets 7 to print only 7 records, okay? And here head function is used to print first few rows of data frame, and if we provide any number inside these brackets, okay, then those many records will be printed. And when I ran the cell, I got the following output. So it printed 7 records here, okay. Moving on to next SQL statement, which is a select statement where we want to filter the customer IDs whose annual income in $1,000 is equals to 16. So this is the condition given here, okay, and we just want to select only those records which has the annual income K dollars is equals to 16. Okay, so if you see here, there are only 2 records here with such condition, okay, where the annual income is $16,000. We have only 3 and 4 customer IDs for that, and you can see the pandas equivalent for this is this particular statement, okay. And here we are actually filtering the records on the basis of single condition only. The SQL statement uses this where clause to filter the records based on particular condition, which is annual income in $1,000 K dollars in fact is equals to 16, okay. The Python equivalent of this query is writing the name of the data frame first here, okay, followed by name of the condition, which is this condition, and attached with, and this condition is attached with the data frame name here inside the solid brackets. Since I wanted to print only customer ID column, hence I attached the customer ID column using a dot operator here at the very last, okay. And when I ran this cell, I got this output, which is customer IDs 3 and 4, okay, which suffice this particular condition. Moving on to next cell, okay, so here in the next cell I'm going a step further to filter records on the basis of multiple conditions. Here the select statement contains a where clause, which is this clause, okay, to filter the records on the basis of 2 conditions, that is the annual income K dollars is equals to 16 and spending score 1 to 100 is equals to 6. So these are the 2 conditions on the basis of which the records will be selected, okay, and we will get the result only when both of these conditions are true. Since there is a star after select statement, so all the columns will be selected here, right? So the Python equivalent of this query is written in the next line, which is this particular line, okay, where we have given the name of the data frame first, followed by the conditions, these 2 conditions inside the solid bracket, okay. And I haven't given any column name at the last here, okay, I haven't given any name column name here at the last after the solid brackets at the end, because I wanted to see all the columns printed, okay. Just like I mentioned the columns here, I didn't mention any column here because I wanted to print all the columns. So when I ran this cell, I got the following output, which actually suffice this condition, okay. So here the condition was annual income K dollars equals to 16 and spending score 1 to 10 should be equals to 6, which is this particular record, right? So the output came as this particular record only. So the next cell, which is this particular cell, is the replica of the previous cell where we were filtering records on the basis of multiple conditions, these 2 conditions. So same is the case here. The only difference is that instead of printing all the columns, I am printing subset of columns like genre, age, spending score 1 to 100, right? So what we will do here is that we will suffix the column names after the solid brackets, okay, here. So we will attach these column names at the end, at the very end, after the solid brackets which contains the conditions, okay. And now in order to print only these three columns, we will enclose them inside two solid brackets, okay. And when I ran the cell, I got the following output. So instead of all the columns, I just printed only three columns having or meeting this particular condition. All right, the condition is same as above, but only difference is that I am printing only three columns here. Here I have all the columns. So in the next cell, I'm using the some built-in statistical functions like mean, max, min, to find out some descriptive statistics on column called age, okay. And the select query here is using these statistical functions by passing column name, which is age, okay, as an argument to these built-in functions, right? So the pandas equivalent statement for the above select query shows the usage of aggregate function here, okay. So this is the aggregate function which we can utilize to find out or perform some statistical operation on a particular column. All right, so this aggregate function contains a dictionary, which is this dictionary, which is enclosed in brackets or curly braces. In fact, here you can pass the name of the column as a key. So this is the key value, which is nothing but the column name, okay, on which you want to perform these descriptive statistics. In the values section, of this dictionary, you can pass a list of functions which you want to perform on that column, okay. So this is the list of functions which you want to perform on this particular column, right? And when I ran the cell, I got the following output where I got the mean value as this 38.85, max value is 70, min value is 80 for age column. Moving on to the next cell. So in the next cell, I'm showing a select query where I'm using distinct keyword to find out the distinct value of the column called annual income K dollars. In Python, if you see, I just use this distinct keyword in the select query, right, to find out the distinct values. So in Python, we can get the same result by making use of keyword called unique, which we can attach to a column, which is this column in our case, to a column of which we want to find out the unique values. When I ran the cell, I got the following output, which shows only unique values and removing any duplicate. So if I see this particular column here at the top, you can see that there are duplicate values here, right? 15, 15, 16, 16, 17, just like that. Okay, so when I ran this particular query or this statement, I got this result where only unique values are listed out. Okay, so these are some of the ways using which we can perform some pandas equivalent operations of select queries. So folks, this is it for this video. I will be covering several other Python pandas equivalent of SQL query constructs. So stay tuned for the next videos. So let me ask you a question from today's video. How can we select only subset of columns in the pandas operations? Please post your comments in the comment section given below so that I can get a chance to incorporate your feedback. You can also post your technical questions in the comment section and I will try to answer the same. If you are watching this video and you are not already a subscriber to our channel, consider clicking that little subscribe button. In case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me guys. I will be covering next topic in the upcoming video. So keep on watching. Thank you.